I mean, well, this is a slightly advanced pattern of Hasura, or like different pattern of Hasura that we're exploring. So just kind of bear that in mind. But the problem statement here that we're looking at is basically saying, hey, we have an existing REST-ish API or a GraphQL API or something that exposes business objects from some system of record, right? Maybe it's a legacy system, it's a legacy database, it's an old service, it's 30 years old, 20 years old, whatever, right? It's a thing that exists. And what we want is you kind of want a GraphQL API on it, right? A Hasura-style GraphQL API, the way Hasura works with Postgres, right? You want permissions, you want pagination, you want sorting, you want aggregations, you want relationships. Now, if you want to get this kind of an API, an existing REST API, it's hard because fundamentally, when you think about features like pagination, sorting, aggregations, relationships, filtering, right, the where clause and nested filtering and all of that, it depends on being able to operate on that piece of data, which is why Hasura kind of exposes those features on when Hasura is giving you a GraphQL API on Postgres, right? So that kind of becomes challenging for Hasura to do when that GraphQL API is just coming from another API service. And that API service itself does not have these kind of advanced capabilities, right? And so that's kind of the problem statement that we have at hand, which is that, how can we start, what is a pattern with which we can get this Hasura style API, but on this existing API where, we don't have any control, we know that it's exposing some objects, but we don't have the flexibility and the queryability that we would have gotten if, that system of record had just been in Hasura plus say Postgres or Hasura and SQL Server or whatever, right? So when we think about, like, that's the problem, that's kind of what we want. Just an important thing to note here is that if you use actions or remote schemas, you could use that to bring in an existing API as well and bring that into kind of like a Hasura powered GraphQL API where you would get things like caching, for example, and monitoring, but you still won't have that kind of advanced flexibility that you would get with, say, row level or entity level permission system, right? That does a predicate push down, or the kind of performance enhancement that you would get when you do relationships and joins where you don't have n+1 problems and you just get a single query that fetches all of the join data or all of the relationship, all of the related data in one shot, right? You won't get that power, but you will be able to expose that as a GraphQL API, which might work, right? So with that caveat, right, like what we're thinking about is noting that we don't want to take this approach, but we do want a powerful API. What does that kind of pattern look like, right? So the idea is really simple. What we do is we'll take models. We'll first create our models in a Hasura plus Postgres system as if that was where the API was always going to be, right? So we design kind of our models in Hasura plus Postgres. We get the GraphQL API. That's the API that we wanted. There's no data inside this because it's not the system of record. The second piece of the problem then is to take that data from our existing API and cache it or materialize it, right, in our Hasura plus Postgres system. So that it's like a materialized view, right, for the API. It's kind of like a materialized view for the API. You're just kind of taking that data and keeping it in a Hasura plus Postgres model. And then, of course, you get to use the Hasura GraphQL API, right? So that's kind of at a high level what we want to do. The details here, of course, like, how do you keep the data in sync? How do you bulk load that? How do you bulk load all of this data? What happens when the data is old? What happens if the data gets deleted? Right? Those are kind of the challenges, and that's kind of what we'll take a quick look at, kind of how we approach that problem. So what we have, I mean, just in terms of an architecture to lay that out for you, is that you have an existing API, and this exists. And then on the other side, what we've done is we have Hasura. We've set up some Hasura models with a Postgres database. We set up our models here, right? So one of the examples I'm going to show you is as if we had like a billing system. There is kind of a bill entity here. What we've done is we want like a GraphQL API for bills in Hasura, right? So what is that going to, that's the model that we set up here. The next piece then is that whenever data changes here, we somehow need that to start populating our data in the Hasura plus Postgres system, right? Oh, great here. This is exactly kind of the problem that you're looking at too. And so when we're thinking about this, how this works is fairly straightforward. What we do is we first set up a sync events table. So we set up a table in Hasura plus Postgres, which basically captures events that are happening, right, in the existing API, so that we can then use that to kind of keep synchronizing data inside our model, right? Think of it like this is our cache. This is the source of truth. When the source of truth changes, we need the cache to get updated, right? So what entities in the cache should we update and when is maintained in this events table here. It's a very simple table. And what it essentially does is it captures an operation that's happened, the name of the model that's changing, and the identifier of what has changed, right? So this is like saying, hey, a new bill got inserted. Bill ID is 45, and it got inserted. Or bill ID is 45, it got updated. It's a bill, right? So this tuple, this kind of three pieces of information, right, are sent to this model here to track the fact that, hey, this has happened. Now we have to do the next step of figuring out how we can synchronize this data here, right? So that next piece is basically a Lambda, like a data sync. It's a Lambda or a serverless function or a web service or whatever. And so that's it's a generic piece of code that Gavin and I worked on and set that up. And this is something that you can kind of use in your own system as well as generic. What this Lambda does is it basically gets triggered whenever there's a synchronization event here, and it then updates the data in our Hasura models here, right? So whenever this event gets triggered, this Lambda goes, fetches the actual source of truth, the raw data. So again, imagining that we had bill ID 45 getting inserted, this Lambda then knows, okay, this was a bill model. Let's go and fetch all of the actual data for 45, for bill ID 45, and then let's go upsert that in Hasura, right? So that if it's an update or an insert, let's use the Hasura mutation, the upsert mutation, right? And let's insert that in here so that we can then get an API off of it, right? That's kind of the high level architecture. And I just kind of quickly, I won't do too much of a live demo. I'll just show you what this setup looks like with the Hasura console for those of you familiar with Hasura, so that you can just kind of map that to how that works, right? So here, for example, I have a sync event table. This is kind of the name of the table that has these kind of synchronization events, right? That's the ID, that's the name of the operation, that's the name of the model, and that's the name of the operation that's happening, right? Now, as soon as this operation happens, it triggers an event, and there's an event trigger here, which is the sync handler, right? So that's the sync handler that's going to be triggered. Let me just full screen this, right? So that's kind of the event handler that gets triggered. Can you folks still see my screen in the Hasura console? Sometimes when I full screen it disappears. Okay, thank you.
Still good.
All right, cool. So as soon as an insert operation happens here, right, our Lambda gets triggered, and what happens is that the raw bill object gets inserted here, right? So as soon as there's a synchronization event that gets added here, right, I can insert one manually. I can have something coming in from any kind of queue that my existing API has, right? Maybe the existing API is publishing business events over an event bus, over Kafka, over whatever, or maybe it's just calling out to maybe it's just making an API call, right, to say, hey, something has changed, right? And then you capture that something has changed information here in the sync table, and then this powers the Hasura kind of quote unquote cache update, right? And so as soon as there's an insert here or an update here, the appropriate entity here gets updated, right, via that event trigger. The nice thing here is that you can actually, because the sync event kind of keeps track of when it was last synced, when this was created, and so you can see a delay, what your typical kind of delay is whenever there is a synchronization, whenever a synchronization event needs to happen, right? And so that typically ends up being, from our observations, maybe about 2 to 3 seconds, right? You can optimize that a little more, but that's kind of the time delay that you would have in an event being published, and then everything getting updated. It obviously depends on your existing API and stuff like that. So that's kind of what this piece looks like. I'll just do another quick look at what it looks like to actually implement a particular mapper. So let me just share that as well. All right, cool. So the work that's required to set this mapping up, right? Because it's custom to your API, it's custom to a model that you have, is you implement a TypeScript interface that essentially has three keys, right? To help keep that data in sync. So you implement just those three pieces and the synchronization gets set up, right? So that's kind of what the data sync Lambda does. And just to show you what that interface looks like, let me just head to VS Code here. It's basically implementing this interface here, right? It's first a query that knows how to fetch the raw data from your existing API. Second, an upsert mutation in Hasura. So that will be an upsert into Hasura to the Hasura kind of, again, quote unquote cache. So you implement this upsert and you add in a GraphQL query here. And then you have a delete, because you might have a delete operation. You want to delete an entity from the cache. So you have a delete operation here, and that's a delete mutation. Again, these mutations are available automatically with Hasura, right? So as soon as you created a model, so as soon as I created the build model in Hasura Postgres, I automatically get an upsert mutation and a delete mutation, right? And then, and this is the critical part, this is a pretty, this is intended to be a simple function that allows you to map the API response into what you want to see in the Hasura model, right? Because sometimes you might not want to have a one-to-one mapping from your API model to what you have in the Hasura model, right? You maybe want to transform something, you want to encrypt the ID, you want to hide some data, right? Whatever it is, you kind of, you can do that mapping here so that you can map that response, right? It basically takes a key value, like an object, and spits out another object, right? Which is going to be what gets absorted into Hasura. So you implement that. It usually would take, maybe for a new model that you have, it would take you between 20 to 25 minutes to set this up for a new model, right? So that means per existing API kind of object type that you want to bring into a Hasura-style thing, it should take you between 20 to 25 minutes to go in, create the Hasura model, write the upsert query, write the delete query here, and then set up the mapping. And then you're essentially done. And as soon as you start inserting events into the sync event table, everything kind of picks up from there. This we'll be publishing this as a open source kind of a module that you can run with instructions on how you can run this Lambda yourself. We'll be sharing that with you folks. Let me just quickly head back to the presentation to wrap that up with, in terms of caveats of when this works and when this doesn't work. So let me just share that with you here. All right. So this works when there are a few conditions, right? It doesn't work if you can't tolerate these conditions. The first is your existing API exposes business objects that can be queried by an ID, right? That's what you want to do with your existing API. There are objects there that can be queried by an ID, because that's what the synchronization system will use to query that raw ID and then populate the Hasura model, right? The second is that your existing API can emit events for business objects that are being changed, inserted, updated, or delete, or they are being published to a queue that is being then sent to Hasura, or you have the tolerance to say, it doesn't get updated too frequently, we'll just do a nightly cron or a 2-hourly cron or whatever, right? Again, it's just very similar to kind of a materialized view pattern, right? Where you're like, hey, I can incrementally maintain the materialized view, right? Or I can just refresh the entire materialized view every few hours or every day or whatever, right? The third is that you can tolerate a little bit of this cache inconsistency delay from when this update happens in your system of record to when the update shows up in Hasura, right? In most cases, this works well. This is totally fine to do, but that is a caveat here because it's not transactional. These are two completely independent systems. The fourth here is that the model that we're also setting up is when you're reading from Hasura, you're still writing to your existing API. You're still probably sending mutations, and you're maybe mapping those mutations with actions or remote schemas, sending that to your existing API. So you're mapping all of your mutations there, and then you're just doing the read from Hasura when you're reading that data, right? And the read API can then have relationships and permissions and all of the stuff that you would get from Hasura. So that's a quick look at this. We'll be open sourcing the data sync module soon. It's already open source. We'll just be packaging that together so that you can check that out and start trying it out and letting us know if this is useful to you, and getting back to us with any feedback that you might have. All right, that's it from me.